Hi everyone. So in this last video for cost volume profit analysis, we're going to be doing one final example, and then we're going to carry on into the margin of safety. So let's begin with this example. So suppose Latin Corporation's break-even point in revenues is $1.5 million, and their fixed costs are $600,000. What we need to do is compute the contribution margin percentage at break-even. So the first thing we want to do is recall our contribution margin income statement. So we have sales minus our variable cost gives us contribution margin. From contribution margin, we'll subtract fixed cost, and that will give us our operating income. So they tell us in the story here that our break-even revenues is $1.5 million, and that our fixed costs are $600,000. And what we remember, at break-even, operating income is zero. And the only way that operating income can be zero in this income statement is if contribution margin and fixed cost are equal. So contribution margin will also have to be $600,000 to make this equation work. So we're basically working backward. If contribution margin is $600,000, then variable cost must be $900,000. So let's go back to the original question. We need to compute the contribution margin percentage at break-even. All right, so recall that we can represent the first three lines of the income statement as a percentage of sales. So sales would be 100% of itself, and then we could figure out what the other percentages are. So for example, contribution margin is $600,000. If we divide that by the sales, $1.5 million, we find that the contribution margin percentage is 40%. So we could put that in our equation here, and if we needed to have variable cost percentage, is simply the difference. So the variable cost percentage would be 60%. But the question asks for the contribution margin percentage at break-even, and that is the 40%. Now let's move to the second half of the question. Compute the selling price if variable costs are $15 per unit. Well, once again, let's start with our income statement. So our sales minus variable cost is contribution margin. We've already found our percentages up above in the first part of the problem. So sales, of course, was 100% of itself. Variable cost were 60% of sales, and contribution margin was 40% of sales. This is going to help us figure out this problem because we're looking for the selling price. So that's going to be our X. And we know variable cost per unit is 15, and we don't really know what contribution margin is. So we can take this information and kind of rearrange it into an algebraic expression, because variable cost, which we know is $15, is 60% of sales, because 60% is our variable cost percentage, which is a percent of sales. Now we can easily calculate X by solving this equation. So we're going to divide both sides by 60% or 0.6, and we find that X is $25. Now another way you could do this, again depending on how your brain works and how you want to kind of see the picture itself, we know that contribution margin percent is equal to the selling price minus variable cost per unit divided by the selling price. So that gives us a new equation of X, because that's the selling price, that's what we're looking for, minus 15, that's our variable cost per unit, divided by the selling price of X, and all that's equal to the contribution margin percent, which we know is 40%. Again, we're just going to solve for X. We'll multiply both sides by X, and then add 15 to both sides to get X on one side by itself. So in this case, X is also $25. So we get the exact same answer here. So keep this information handy. For the next slide, we're going to be talking about margin of safety. And we're going to use this data for an example about margin of safety. Okay, so let's first start off with defining margin of safety. So the margin of safety is basically how much your sales can fall before you begin to incur a loss. We can think about margin of safety in the terms of revenues and break-even revenues by taking revenues, our normal revenues, and subtract our break-even revenues, and that will give us our margin of safety. So we're going to use the Latin Corporation from the prior slide as an example to calculate margin of safety. So in this case, we're going to suppose that 80,000 units are sold, and we're going to need to compute the margin of safety in both units and in dollars. So let's first calculate the margin of safety in dollars. So for Latin Corporation, we computed a selling price of $25 per unit. So if we're selling 80,000 units, that would give us our revenues, our normal revenues, and we know that our break even in revenues from the prior screen was $1.5 million. So once you calculate this $25 times 80,000 units, you find that to be $2 million, and we subtract that and we end up with a margin of safety of $500,000, so $500,000. So again, this means that our sales can drop by $500,000 before we begin to incur a loss. So now let's calculate our margin of safety in units. Well, our normal sales in units is 80,000. And now we want to know, well, what's our break even in sales units? Well, if our break even in sales dollars is $1.5 million, and we sell each unit for $25, if we divide the total break-even sales by our per unit sales of $25, we find that the break-even in sales in units is 60,000. And then we could subtract the two to get our margin of safety of 20,000 units. So sales would have to drop by 20,000 units from what they currently are before we would begin to incur a loss. So a couple other ways you could actually find this one number of $20,000. You could also take the $500,000 of your margin of safety in dollars and divide that by the $25. That would also give you the $20,000 rather quickly if you wanted to do it that way.